1. Dunkleosteus, the armored executioner. Imagine swimming through a dark prehistoric sea. Then suddenly, a massive shadow turns toward you. No rows of razor-sharp teeth, no terrifying roar, just two enormous bony blades snapping together faster than your eyes can react. Meet Dunkleosteus, one of the first true apex predators the oceans had ever seen. Living roughly 360 million years ago, during the late Devonian period, this giant armored fish measured between 6 and 10 meters long and may have weighed nearly 4 tons. At a time when most marine animals relied on speed or camouflage, Dunkleosteus relied on something far more brutal: raw mechanical power. Instead of teeth, its jaws were made from sharpened bony plates that continuously sharpened themselves as they rubbed together. Scientists estimate those jaws could generate more than 6,000 newtons of bite force while closing in as little as 20 milliseconds, faster than the blink of a human eye. That incredible speed allowed it to ambush prey before they had any chance to escape. Large sharks, armored fish, even members of its own species may have fallen victim. But perhaps the most surprising discovery came from its fossils. Many skeletons show partially healed bite wounds. That means these monsters weren't just hunting everything else. They were fighting each other. Dominance in the Devonian Ocean came with a brutal price. Yet even an armored giant couldn't escape extinction. Around 359 million years ago, a series of global environmental crises dramatically reduced oxygen levels in the oceans. Entire marine ecosystems collapsed. Without enough prey, and unable to adapt quickly enough, the reign of Dunkleosteus came to an end. But evolution had already learned an important lesson. Heavy armor could dominate the seas, until something faster arrived. Cameroceras, the first true giant. Long before sharks became the rulers of the sea, before reptiles learned to swim, the oceans were already hiding a monster that looked like it belonged on another planet. Meet Cameroceras, one of the largest predators of the Ordovician oceans, living roughly 470 to 460 million years ago. Scientists estimate it could reach 8 to 10 meters in length, making it one of the biggest hunters of its entire era. But here's what makes it so fascinating. It wasn't a fish. It wasn't a reptile. It wasn't even remotely related to sharks. Cameroceras was an enormous cephalopod, a distant relative of today's squid, octopus, and nautilus. Its body was protected inside a long cone-shaped shell that acted like natural armor, while also helping control buoyancy. Extending from that shell were powerful tentacles designed to seize struggling prey. At the center sat a hard, parrot-like beak capable of crushing shelled animals with remarkable force. Unlike many modern predators that chase their victims over long distances, Cameroceras likely relied on patience. It drifted almost silently through ancient seas before accelerating with powerful jet propulsion, firing bursts of water from its siphon like an underwater rocket. For trilobites, primitive fish, and smaller cephalopods, there was almost no warning. Perhaps the biggest surprise is that for decades, scientists believed Cameroceras was much larger than current estimates, possibly over 15 meters long. More complete fossil discoveries later suggested those early estimates were exaggerated, but even at around 9 meters, it remained one of the dominant hunters of its time. Its reign eventually faded as marine ecosystems changed and faster, more agile predators evolved. Heavy shells that once offered protection slowly became a disadvantage in increasingly competitive oceans. Nature had discovered that speed could sometimes beat armor, and the next predator would prove exactly that. Helicoprion, the shark with a circular saw. Imagine finding a fossil that looks like a perfectly coiled buzzsaw. Now imagine trying to guess where it belonged. For nearly a century, scientists had absolutely no idea. Some believed it sat on the creature's nose. Others thought it belonged on the dorsal fin. The truth turned out to be even stranger. Meet Helicoprion, a bizarre shark-like predator that lived during the Permian period, around 290 to 250 million years ago. Growing to approximately 6 to 7 meters long, Helicoprion looked fairly ordinary, until it opened its mouth. Instead of replacing old teeth like modern sharks, every new tooth grew directly behind the previous one. Over time, those teeth curled into an incredible spiral, called a tooth whorl, containing well over 100 individual teeth in some specimens. Modern CT scans finally solved the mystery. The spiral sat inside the lower jaw. As Helicoprion bit down, prey was pulled inward, while the rotating tooth whorl sliced through soft tissue with extraordinary efficiency. It was less like being bitten, and more like being drawn through a moving blade. Scientists believe it specialized in hunting soft-bodied prey, such as squid and ancient fish, using its unusual jaws to grip animals that would otherwise slip away. Yet one question still remains. No living animal has ever evolved anything quite like it again. Helicoprion may represent one of evolution's boldest experiments, an idea that worked for millions of years before disappearing forever. When the catastrophic Permian-Triassic mass extinction struck roughly 252 million years ago, nearly 90% of marine species vanished. Helicoprion disappeared with them. But after Earth's greatest extinction, the oceans were left almost empty, and nature doesn't tolerate empty thrones for very long. Thalassomedon, the ghost, with a 6-meter neck. When most predators think about attacking, they charge, they chase, they overwhelm. Thalassomedon did something far more unsettling. It barely moved. Living around 95 million years ago during the late Cretaceous, this enormous elasmosaur stretched nearly 12 meters from nose to tail. Half of that length, almost 6 meters, was its neck. At first glance, it looked completely impractical. A body too bulky, a neck too long, too slow to survive. But evolution rarely wastes energy. Instead of swinging its entire body toward prey, Thalassomedon only had to move its neck, while its massive body remained almost invisible in the darker water below. Its small head could glide silently toward schools of fish or squid before striking with astonishing speed. Imagine trying to watch a hunter, only to realize the dangerous part wasn't the body. It was the 6-meter spear, quietly approaching from another direction. Scientists have discovered smooth stones called gastroliths inside several elasmosaur fossils. These stones may have acted as ballast, helping stabilize the animal while swimming. Others believe they also helped grind food inside the stomach after swallowing prey whole. Because chewing, that simply wasn't necessary. For millions of years, this strategy worked beautifully. But near the end of the Cretaceous, the asteroid impact that transformed Earth forever also devastated marine ecosystems. Food chains collapsed. Large marine reptiles disappeared alongside countless other species. The silent hunter was gone. Yet the oceans weren't finished building giants. The next creature abandoned stealth completely, because it didn't need to hide from anything. Leedsichthys, the gentle giant, surrounded by monsters. Not every giant in prehistoric oceans was a killer. Some survived by doing the exact opposite. Meet Leedsichthys, the largest bony fish ever discovered. Swimming through Jurassic seas around 165 million years ago, scientists estimate it reached 16 to 17 meters in length, with some researchers suggesting exceptional individuals may have approached 20 meters. That made it longer than many modern buses. Yet despite its incredible size, it hunted nothing. Instead, Leedsichthys fed on microscopic plankton. Its enormous mouth filtered thousands of liters of seawater every day, trapping tiny organisms much like today's whale sharks or baleen whales. It's almost impossible to imagine. An animal weighing tens of tons, living on creatures smaller than a grain of rice. But there was a problem. Being enormous doesn't automatically make you safe. Unlike heavily armored predators, Leedsichthys had relatively soft tissues and no powerful weapons for dents. Young individuals were almost certainly vulnerable to giant marine reptiles such as pliosaurs. Even adults may have carried scars from failed attacks. Its greatest strength was simply becoming too large to hunt efficiently. Ironically, scientists know surprisingly little about Leedsichthys because its skeleton wasn't built from dense bone. Many fossils were made of cartilage-like material that rarely survived the fossilization process. We're still piecing together its true story today. Eventually, environmental changes and shifting ecosystems brought its era to an end. But something extraordinary was about to happen. For the first time, the oceans would no longer belong to reptiles. A completely different group of animals was preparing to take over, and they still walk the earth today. Mosasaurus, the tyrant that returned to the sea. Sometimes evolution does something completely unexpected. It spends millions of years helping animals conquer the land, only for one of them to turn around and dive straight back into the ocean. Meet Mosasaurus, one of the last and arguably most successful marine reptiles ever to exist. Living between 82 and 66 million years ago, Mosasaurus grew to around 12 to 15 meters in length, although the largest known species may have exceeded 17 meters. From a distance, it looked like a crocodile. But that comparison doesn't even come close. Its closest living relatives aren't crocodiles at all. They're monitor lizards and snakes. That means one of history's greatest ocean predators actually descended from land-dwelling reptiles. Its body was built for speed. A powerful crescent-shaped tail delivered explosive bursts of acceleration, while paddle-like limbs gave it incredible control beneath the waves. But its most dangerous feature was its mouth. Mosasaurus possessed dozens of backward-curving teeth, designed to grip prey so tightly that escape became nearly impossible. A second row of teeth on the roof of its mouth helped drag struggling victims deeper with every bite. Fish, sea turtles, large marine reptiles, even smaller mosasaurs. Nothing was completely safe. Fossils bearing healed bite marks suggest these giants often fought each other over territory or food. In the late Cretaceous ocean, even the apex predator wasn't immune to becoming someone else's next meal. Then came the day everything changed. Around 66 million years ago, a massive asteroid struck Earth near present-day Mexico. Global wildfires, towering tsunamis, months of darkness, marine food chains collapsed almost overnight. Within a geological instant, the greatest marine reptiles disappeared forever. For a while, the throne of the ocean sat empty, but evolution hates an empty throne, and the next ruler wouldn't be a reptile. It would breathe air, feed its young with milk, and eventually grow even larger than any predator before it. Mana for fana. Basilosaurus, when whales were hunters. When you hear the word whale, you probably imagine a gentle giant drifting through the ocean. Basilosaurus was nothing like that. Living around 41 to 34 million years ago, during the late Eocene, this early whale reached an astonishing 15 to 18 meters in length. Its body was long and serpent-like, allowing it to weave through coastal waters with surprising agility. Despite its name, meaning king lizard, Basilosaurus wasn't a reptile. Early paleontologists misidentified its fossils before realizing they belonged to one of the first fully aquatic whales. That mistake became permanent history. Unlike today's baleen whales, Basilosaurus had a mouth full of sharp differentiated teeth, built for tearing flesh. Fossil evidence shows it hunted large fish, sharks, dolphins, and even smaller whales. Some juvenile whale fossils have been discovered with unmistakable bite marks matching Basilosaurus teeth. It wasn't simply another predator. It was the first whale to become an apex hunter. Here's the detail that fascinates scientists most. Hidden near its tail were tiny hind limbs, each only about 60 centimeters long. They were far too small for walking, far too weak for swimming, yet they remained as silent reminders of ancestors that once walked across dry land. Evolution doesn't erase history overnight. Sometimes it leaves behind tiny clues. As Earth's climate continued cooling, ocean currents shifted dramatically. Marine ecosystems changed, and Basilosaurus eventually vanished. But its descendants adapted. Instead of disappearing, they evolved into the whales we know today. The age of giant marine reptiles had ended. The age of marine mammals had begun. But our final predator would become something entirely different. Not a reptile, not a whale, a hunter, so efficient that its very name still captures our imagination millions of years later. And it may have been the greatest shark that ever lived. Megalodon, the last true king of the ancient oceans. For more than 400 million years, the oceans kept creating larger, smarter, and deadlier predators. Every extinction seemed to erase one king, only for another to rise. Then came Megalodon, not the first giant, but perhaps the most perfectly engineered predator evolution had ever produced. Living between 23 and 3.6 million years ago, Megalodon reached an estimated 15 to 18 meters in length, with some studies suggesting exceptional individuals may have approached 20 meters. Its weight likely exceeded 50 to 60 metric tons. To put that into perspective, an adult great white shark would have looked surprisingly small beside it. But size wasn't what made Megalodon terrifying. Efficiency did. Its jaws were armed with nearly 270 serrated teeth, each reaching up to 18 centimeters long. Scientists estimate its bite force at well over 100,000 newtons, with some biomechanical models placing it closer to 180,000 newtons, one of the most powerful bites ever calculated for any animal. It didn't need to chase prey for hours. It simply had to land one devastating bite. Fossilized whale bones tell the story. Many preserve deep matching bite marks across the ribs, flippers, and tail. Paleontologists believe Megalodon often targeted the tail first, crippling massive whales before delivering the final attack. It hunted strategically, not recklessly. And here's something many people don't realize. Megalodon never shared the oceans with dinosaurs. It appeared more than 40 million years after the non-avian dinosaurs disappeared. Its true rivals weren't giant reptiles. They were whales. Ironically, the very animals that helped Megalodon become enormous may also have contributed to its downfall. Around 3.6 million years ago, Earth's climate cooled dramatically. Sea levels dropped. Many warm, shallow nursery habitats disappeared. Whale migration routes shifted toward colder waters where Megalodon struggled to thrive. At the same time, faster predators, such as the ancestors of today's great white sharks and growing populations of orcas, competed for food. The king didn't lose a single battle. It lost the world that had allowed it to rule. And that may be the most important lesson, hidden beneath millions of years of evolution. In nature, being the strongest has never guaranteed survival. Only adaptation does. Today, the oceans no longer belong to monsters the size of buildings. But every great white, every orca, every sperm whale, carries a small piece of the evolutionary legacy left behind by these forgotten giants. The age of prehistoric sea monsters may be over, but the story of ocean predators is still being written. From armored fish that could slice through bone, to serpent-like whales, to the largest shark ever known, Earth's oceans have been home to some of the most extraordinary predators evolution has ever created. Now it's your turn. Which ancient sea predator do you think would have been the most terrifying to encounter face to face? Let me know in the comments below. And if you enjoyed exploring the lost rulers of the ocean, don't forget to subscribe, because next time we're uncovering another chapter from the most dangerous history our planet has ever known.